Hello everybody and welcome to my research efforts and accomplishments presentation for the conclusion of the spring 2019 semester. Today I'm going to be talking about some of the major research activities that I've been working on in the past year, and handily I made this table earlier this week that kind of provides everything that I've done. So as many of you know, I've worked on both hurricane projects and wildfire projects, both encompassing the concept of grid resilience. And so this table shows an overview of everything. So in the last summer, I worked to develop a hurricane resilience model that many of you are probably familiar with, called the STIA model. This model has since been used in a couple of our lab's other projects. So for example, my initial goal with this was to see how energy storage could be used, operated in a preparatory manner to mitigate impact from hurricanes. So those of you who were in power systems security with me last spring kind of understood what this was all about. Basically, the concept is to charge up energy storage in the hours and days before a hurricane as it's approaching, and then use that stored energy post-contingency to selectively restore load based on load criticality. Then some of my additional research work has been funneled into this other project that I worked on with Alex last semester. Here we made a web-based visualization in JavaScript, and we did a lot of the data management in Python as well. We worked with another student from computer science to develop this visualization. So I'd encourage you guys to go check it out. It's on the USMART website if you'd like to see it. It offers some pretty interesting insights into 3 recent hurricanes and the power outages that occurred. Alex and I are currently working to improve this visualization, and we hope to turn it into a paper, probably a conference paper. So if any of you have any ideas for visualization related conferences, please let us know. Then moving on to my wildfire work, the first thing that I worked on was a collaboration with Amara. In this project, we considered non-power system caused wildfires, and the goal was to use historical wildfire data as well as high resolution weather data to in a Monte Carlo scenario. So basically generate stochastic wildfire ignitions, model how the wildfire spreads, and then as it gets close to the power systems within a certain distance, then you consider an outage basically. So here's some of the results on the right of that work. Still has yet to be turned into a paper, but I think decent progress has been made there. Additionally, I then kind of decided that rather than look at externally ignited wildfires, I wanted to look more at power system related failures and caused wildfires, because that's what a lot of the power industry seems to be focused on these days. So then I started looking at how can high resolution weather forecasts help to indicate de-energization on the transmission system. So here, for example, you see on the left a fire weather index that takes into account a number of different weather parameters, such as temperature and relative humidity, as well as wind speed, and summarizes that in a forecasted fire weather index. And on the right here, you see basically I simulated PacifiCorp's wildfire threshold. So these are all the locations within that study area where, based on PacifiCorp's threshold, they have decided that it exceeds wildfire danger and thus some action should be taken. So done some work into some investigation into this, and I think this is also promising. Looking forward to seeing how I can kind of wrap this and perhaps the previous model up into a single paper. And then the final thing that I've been working most recently on, which has been a really interesting project. I've been working on this with Hugh. Um, Basically, we took a couple of different concepts. The first are wind speed fragility curves, which were used in my STIA model to simulate line failures, and then additionally, um, referencing another paper determining how atmospheric conditions dictate whether or not arcs will cause ignition of brush surrounding the line. So this is something I'm currently working on, basically a Monte Carlo simulation that simulates both line failures and then as a result arc ignition. This is really what I think is going to be a really beneficial concept to develop, and I've been working with Hugh on this for the past few days. Really interested to see kind of where this goes. And then finally, I just want to mention I did work for this Introduction to Data Science project. First of all, I would say I would highly recommend this course for anybody interested in learning Python, or who will be using Python in their research. It was far superior to MATLAB in many ways, and now that I know it, it's absolutely changed the way I do my work and my research. So this is a machine learning model that I put together in this class that basically took 2.5 years of historical California ISO energy consumption. This is daily consumption, and then predicted for the year of 2018. So I used both a linear regression and a neural network to make these predictions. If you'd like to see a 3-minute video overview, ask Roy. I sent it to him in Skype the other day. And I'm going to be in Fort Collins this weekend with my family, and thank you for your time.